Well, here we're doing absolute value inequalities, and we're going to solve and graph, and then the solution's going to be put in interval notation. So our goal initially is to get rid of these absolute value bars. Well, we can do that quite simply if the orientation of that inequality is pointing left. In other words, if it's something like that or like that, less than or equal to, then we can simply dispense with the absolute value bars by going -4 in this case is less than x plus 3, which is less than 4. And if we went through the two-case thing, we'd wind up with this conclusion, but since it works that way every time, if the orientation of the inequality is to the left, why not just cut right to this? Now, our goal is to isolate x. So we have to get rid of this 3, so we'll subtract 3 from each interval. And we get -7 is less than x, and -3 plus 3 is 0, so less than x, which is less than 1. Now we're ready to graph, and so we'll do a number line, x, and we've got a hash mark at -7, open circle, and a hash mark at 1, another open circle, no equal signs associated, and x is all the values between these two numbers. So there's our solution graphically. In interval notation, that's going to be -7 to 1, and we're going to use parentheses because there's no equal sign associated with the inequality or inequalities. So this is not an ordered pair. This is an interval, and we've got it. Well, now we have another inequality to deal with, absolute value inequality. And because the orientation of the inequality is pointing to the right, we have to use the two cases to. And so one of the cases is 2x minus 6 is less than 0. The other case is 2x minus 6 is greater than or equal to 0. There we go. If this is the case, then our goal again is to dispense with the absolute value bars. We can write 2x, and I'm sorry, that should be a -4, not a -6, -4. There, 2x minus 4. 2x minus 4 is less than or equal to -6. Notice we flipped the inequality, and we also changed the sign on the 6. Now, if this is the case, 2x minus 4 is greater than or equal to 0, then we're going to have 2x minus 4, and we can simply dispense with the absolute values bars, and we get 6, see? So now let's solve this, and first goal is to isolate the term with x in it, then we'll isolate x. So I guess we'll add 4 to each interval, or each side of the inequality, and we get 2x is less than or equal to -2. Yeah, -6 plus 4 is -2. And now we'll divide both sides by 2, and we get x is less than or equal to -1. Now let's do this one. And so we'll add 4 to both sides. And now we have 2x isolated, and that's going to be 4 and 6 is 10, isn't it? So then we'll divide both sides by 2, and we get x is greater than or equal to 5. So we're ready to graph. Let's get that job done. X, and here we are at -1, and x is less than or equal to that, so we'll put a solid circle and hash mark at -1. Now we're going to have a hash mark at 5, solid circle, because we've got an equal sign associated with that inequality. And there we have it. X is all the values greater than 5. So in interval notation, what we get is negative infinity to negative 1, bracket and a parenthesis on the left, union with, which represents the word or, but we have to write union. That's part of the interval notation language. And now we'll put a 5 to infinity. Smaller values in interval notation, smaller values to the left, larger values to the right, and there's our guy right there. Here we are, one more absolute value inequality to take on. So, look, our first goal now is to, we've got to get the absolute value all by itself, and then we can go from there. So to do that, I guess we better subtract 6 from both sides. And we get negative 3 then, times the absolute value of 1 minus 4x is less than negative 9. Now, we still are encumbered by that negative 3 there, so we'll divide both sides by negative 3. And if we divide negative 3 by negative 3, we just get a 1, so we just get the absolute value on the left. Now when we divide through by a negative, we have to flip the inequality. And dividing negative 9 by negative 3, we'll get a 3. And now we're ready to go. So we've got a two-case thing here. And so we have the case where 1 minus 4x is less than 0, or 1 minus 4x is greater than or equal to 0. Those are our two cases. So, and they enable us to dispense with those absolute value bars. So if this is the case, then we're going to have 1 minus 4x is less than negative 3. Notice I flipped the inequality and replaced 3 with negative 3. Here we can just drop the absolute value bars and we get 1 minus 4x is greater than 3. Now, our goal is to isolate the term with x in it, and then we'll isolate x. So I guess we'll subtract 1 from both sides. And we get negative 4x is less than negative 4, and dividing through by negative 4 we get x, and we have to flip the inequality, is greater than 1. Now let's go over here and we'll subtract 1 from both sides, and we get negative 4x is greater than 2, and we'll divide by negative 4 again, so we're going to have to, dividing by a negative, we have to flip that inequality, and we get x, and 2 divided by negative 4 is negative 1/2. So now let's draw our graph, and we've got a hash mark at negative 1/2 and an open circle and everything to the left. And then we have a hash mark at 1. That's going to be an open circle and everything to the right. And so in interval notation, our solutions are shaded. Interval notation, we have negative infinity to negative 1/2, and that's parentheses in each case, union with 1 to infinity, and we have it.